let's do some examples of Gibbs free energy and electrochemistry. Let's start with this one. Given this reaction, 2SO2 combining with oxygen to form 2SO3 molecules. So everything's in the gas phase here, and we're given the following. It says, if the equilibrium constant is 10 at 960 Kelvin, then calculate delta G and indicate the direction of spontaneous reaction if initially we have the following partial pressures. So inside your reaction vessel, right, inside this reaction, we've got SO2, we've got O2, and we've got SO3, and we're given partial pressures of all three of those things. What it wants us to know is, all right, under that snapshot condition, is the reaction going to proceed forwards and create more SO3 molecules, or will it proceed backwards and decompose SO3 molecules to form the other two reactants, right? So how do we do this? So let's start with the information they've given us. They've said that the equilibrium constant is K equals 10. What do we know about equilibrium constant? When we're using K, Q equals K when what? At equilibrium. And how do we define equilibrium? When delta G for the reaction equals 0, right? Therefore, if delta G equals 0, what is our expression for delta G normally? Delta G is normally delta G naught, our formation condition, change in formation under standard conditions, plus RT natural log of Q. And we're going to substitute K in for Q under this condition where it equals 0. So now it's 0 equals delta G naught plus, let's plug in the gas constant, 8.314, that's joules per mole Kelvin. This is all happening at 960 Kelvin. And then we've got natural log of, we're given the equilibrium constant is 10. Okay? So when I plug those things in, we're able to solve for delta G naught, and I get that it's equal to negative 18,378 joules. So delta G naught is equal to, let's give ourselves a little more room here, negative 18,378 joules per mole. Okay, that's not what we were asked to solve for, though. We were asked to solve for delta G, not delta G naught. So if we want to solve for delta G, we now know delta G naught plus RT natural Q. The only thing we need to figure out is Q for these exact conditions. So it's going to be products over reactants. So let's write out what Q would be. Q, for those starting conditions, is going to be, again, products over reactants. So it's going to be the partial pressure of SO3, and that's going to be squared because there is a 2 coefficient in front of it. And then the reactants, we've got partial pressure of oxygen, don't do anything to that, multiplied by the partial pressure of SO2, and that is also squared. So let's plug those numbers in. When we plug them in, I get that that's equal to 0.05. Okay, so now we know Q, we know delta G naught. This is trivial, we just plug everything in. Let's go ahead and get that done. So delta G is going to be equal to negative 18,378 joules per mole plus 8.314 joules per mole Kelvin multiplied by 960 Kelvin multiplied by the natural log of 0.05. When I plug all of those into my calculator, I get that it's equal to negative 42,288 joules per mole. So now to finish this question, indicate the direction of spontaneous reaction. Well, we just found that with these initial starting conditions, if those are the reactants present, reactants and products present, the change in free energy for that reaction is a big negative number. So that means that the reaction as written is going to proceed forwards. We're going to continue producing SO3 molecules.